Hello, my name is Brian Early, and today I'll be doing my protocol presentation. This is for my network support management class. So the proposal information. So first off, what we need to do is make the two networks IPv6 from their private IPv4 addresses. This is just because IPv4 is slowly not being used. But also there needs to be a 25% growth for the subnets. So just gotta take into consideration upgrade, having more subnets because of growth for more PCs. Also, any upgrades that are needed for hardware must be listed with their prices, as well as upgrading to a 1 gigabyte per second network. And the reason why this is such a big deal is that there's a lot of things in this network right now that are not able to go to a 1 gigabyte per second network. So there's going to be some changes that we'll have to make. So first off, what is IPv6? IPv6 is pretty much just like IPv4 in the fact that they both, are used for addressing. But the big difference is how many bits they are. The IPv6 address is a 128, and as everyone knows about IPv4, it's only 32 bits. So right here is just an example of an IPv6 address, just to show what it looks like. And right here, it's the same address but abbreviated. So it's still pretty big, and it's still bigger than IPv4 address, but there are ways of making them smaller by with the more amount of zeros. You could just abbreviate it, as you can see. So why is IPv6 needed for this company? And the main reason, which is one of the proposal reasons, is because of growth. So with this growth, IPv4 is not going to be able to supply that demand. So this is also why a main reason that a lot of people are switching from IPv4 to IPv6. And also, IPv6 has done some things in preventing some of the IPv4 problems. It's a little bit more secured, and overall, it's better laid out. So right here is just an example of how much bigger IPv4 is than IPv6. This is just showing the difference between addresses. As you can see, IPv6 has 10 to 15 times as many addresses than IPv4. And this is just because of it. I mean, there's so much more to work with than with IPv4. So right here, I'm just showing the three parts to an IPv6 address. You see, it's just like an IPv4 address, but instead of using a subnet mask, the subnet ID is already implemented into the address itself, which honestly makes it a little bit easier to understand. And so right here is just the East Coast network. This is before anything has been done to it. And just beforehand, there's going to be a lot of changing up. A lot of almost all the switches will be moving around, as well as some of the routers will be changing. Right here is just a picture of the East Coast network subnetted with IPv6. So as you can see, I'm using a /122, and just the reason for this is because of host reasons. There will be about 64 hosts on each of them, and this is plenty for the growth that it's asking for. And most people though use a /60 just because there's so many addresses, it doesn't really matter. But in this case, we're using a /122 just to work on still conserving those addresses, even though they're enough. And right here is just the West Coast network. This is before I've done anything to it, as well as with the other network. And then here it is subnetted. And as you can see, I'm not using a /122 anymore. It's a /123. And basically, you'll have 32 hosts instead of the other. This is because this network is way smaller than the other one. So there's no need to use a /122 whenever you can just use a /123 and get the same amount out of it. This one will also have some changes to it, but not as many as in the other case. So first, what are the upgrades that are needed for the routers? Basically, all of the 1841 routers need to be changed out. And the reason for this is because they're out of date. Cisco doesn't supply them anymore, and they don't want anything to do with them, honestly. So you're gonna have to upgrade those. And so what we're doing is we're just gonna upgrade those to a 1941 router. And the overall cost for both of these for these networks is $2,985. But if you want them separate, the East Coast network will be $1,990. This is for 3 routers. And then the West Coast will be $995. And this is just for 2 routers. And the reason why the East Coast network costs more is just because there's another router that we're having to pay for. And just the reason for this is because the East Coast network is a lot bigger than the West Coast. So the East Coast will be making a lot more changes than the West Coast will be making changes. So now it's time for the switches, and a lot of the switches will have to change. All of the 10/100 24-port switches must be taken out. So any switch that's a 10/100 24-port switch has to be removed automatically, and this is just solely because of the fact that it's not able to run at the speeds of a 1 gigabyte per second network, and this was one of the demands that is needed for the proposal, so that just has to happen. So first off, for the East Coast network, we will need to change out 4 of the switches that need to be Cisco 10/100/1000 48-port switches. This is for the growth reason. There's a 25% growth, so what's going to be happening is there will be more than 24 people on some of the PCs, or on where a switch would be at for the users, and that's just because of the growth. So that's the reason why they're changing to a 48-port switch. And what we can do is for those 48-port switches I'll be changing out for the 24 ports, is we can just keep those, and we can use those to change out all the 10/24-port switches. So what will happen is we won't have to pay for any 10/100/1000 24-port switches, because all we're doing is replacing those with the 48s. So we can just throw the 10/100s away and just use what we have, and we'll only be spending around $1,180 for this network. And that's a lot of money that we're saving just by using what we still have and making it useful. And then for the West Coast network, we'll need to change out 3, but we'll only need to pay for 2. So the 10/100 port switches for 10/100/1000, this will cost $500. They will also need one 48-port switch for the 18 users. This is just in case of the growth, and this will only cost $295. And you see that it would have costed us about $750 for the 10/100/1000 24-port switches. But what we're doing is we're saving that switch that was used for where the 48-port switch is going for the 18 users. So we're saving about $250 just because we're preserving what we still have and not throwing away. So we'll only be throwing away a couple 10/100 port switches, and still this is just because of the fact that it's not used. We can't use that for the speeds that we're wanting, which is the 1 gigabyte per second speed. So why are they needed? As I was saying, the reason why the routers need to be changed is because they're no longer supported by Cisco. And so if we're using Cisco products and Cisco doesn't support them anymore, that it's going to be a problem. So we're going to have to change all those and make sure Cisco is still up to date with what we're using. And same. And the switches that need to be changed out from 24 to 48, this is only because of the growth problem that we're having. So with the growth, it's going to make us change out some of the 24-port switches to 48. There are also switches that need to be changed from 10/100 to 10/1000 or 10/100/1000, so they can run at 1 gigabyte per second. And this is what I was talking about in the last slide, that we just have to make sure that we're not using any 10/100 switches, just for the fact that we're trying to run at 1 gigabyte per second, and those switches can't handle that, so that they have to be upgraded. And right here is just a summary of what we need. So both of the Megacorps networks are subnetted and ready for use. They are also ready for a 25% growth, and can even do more because of how much that we're able to have with a 122 and a 123 subnet. And all routers will be ready. All switches will be ready for the 1 gigabyte per second. Overall, the expenses will be about $4,460. And some money once was saved, like I was saying, because we're saving the 10/100/1000 24-port switches that were replaced for the 10/100/1000 48-port switches. And so we're saving a good amount of money for for all the changing that we're doing, but we are getting rid of the 10/100s no matter what, just because they're obsolete for us and they're not useful anymore. And that is it. Thank you for watching.